When you cube a negative, it remains negative. If you go left 2, negative 2 cubed is negative 8. And that's the same method that we used graphing back in chapter P, which was, yes, the first week of the year, and chapter 1, which is probably the third or the fourth week of the year. It was a long time ago. We were like in early September when we started chapter 1, since we started school so early. But I'm not making a t-chart. I'm using the power of x. Whatever my x number is, I'm cubing that number to get to the vertical point. So looking at number 2, we have a square root of x minus 1. What's a square root graph look like? David? Yeah. So it's just the half. It hooks one way because it has to be positive. That's why you don't have like 2 pieces to the graph. You just have a half. And David, what's the x minus 1 do?
Does it move it down 1?
So if it's with x, it's going to move it left or right when it's with x.
So then it would be, is it the opposite?
It is,
right one?
yeah. So it's the opposite, so it's going to move it right 1. So when it's with x, it goes left or right. When it's not attached with x and it's outside, then it moves up or down. So because it's minus 1, whenever it's with x, it goes the opposite direction, so it actually moves to the right one. And then doing the same thing with x, we're now square rooting x. So if I move over 1 for x, the square root of 1 is still 1. If I move over 4 for x, what's the square root of 4? 2. So then I move up 2. If I go over 9 for x, the square root of 9 is 3. So I would move up 3. So however far you're moving for x, you're then taking the square root of it, or you're cubing it, David.
But it's not the x point on the graph.
Correct.
Right?
It's right.
It's
So
from that
just from that point, from the starting point. So I'm moving 1 from the starting point. The square root of 1 is 1. I'm moving 4 from the starting point. I didn't move 4 here. I moved 3. There we go. I'm moving 4 from the starting point. I'm moving 9 from the starting point. So you get your new location, and then from that location is where you're going right or left. Questions? Now let's get one here. So the third one, Jared's not here to yell at me. Yeah, I really do think it's magic. For me, at least, it works.
Or that's like its purpose. That's like
Emily, if you start to freeze over there, because Zach's not going to tell me he's freezing.
I'm pretty warm right now.
Yeah, right? So I turned it down. Hopefully it helps. I'm trying to help you out over there. Number 3, we have x plus 1 squared minus 3. Anna, what kind of graph is it when it's squared?
Isn't that a parabola?
It is a parabola. How does it move with the plus 1 inside with x?
That would be left 1,
And then the minus 3.
down 3.
Good. So left 1 and down 3. So backwards 1, down 3. That's the vertex of our parabola. And then from that point, I'm going right 1. 1 squared is 1. From that point, right 2. 2 squared is 4. Right 3. 3 squared is 9. 4. What's 3 squared? 9, right? That was right. I don't know why I didn't think it was 9. There we go. And then because it's a parabola, if you go the other direction, even if you square a negative 1, it's still 1. Squaring a negative 2 is 4. Squaring a negative 3 is 9. But again, it's from your vertex that you're moving. You're not using the plus 1 and the minus 3 in the problem. Those points should line up with each other because that has symmetry. So graph number 4. Ethan, what kind of graph do we give with number 4? Just a line. What's the equation of this line?
Y equals 2x minus 6.
Right, 2x minus 6. Subtract the 2x, divide by a negative 1, y equals 2x minus 6. Ethan, when you have a line, how do you start graphing a line?
I think the negative 6, that's going to be that x equals 0, y equals 6.
Good. So that's that y-intercept. And then you move using rise over run. So we're going up 2 over 1. Question. So number 5, we talked about way back when we were doing the unit circle and trig, and we were finding angles of any value for any value trig functions for any angle. I think is how it was described in section 4.2. And then actually at the beginning of this chapter, we also talked about this graph. If you have x squared and y squared, do you remember?
Circle.
Yeah, this is a circle. So when both the x and the y squared, it's a circle. We talked about the unit circle being x squared plus y squared equals 1 because it has a radius of 1. If it's not a unit circle, we use this form, x squared plus y squared equals r squared. And we said that the r was the radius of the circle, and I could find the sign by taking the opposite side, which was y, over the radius, which was r. That was the form that we used way back in the initial days of trig. So if we have x squared plus y squared equals 9, what's the radius of that circle? 3. So the radius of this circle is 3. That 9, if you square root it, gives us our radius. The center of the circle is however x and y are shifting. Well, if there's not a number with x and there's not a number with y, what do you think the center of the circle is? It's at the origin, yeah. So when you graph a circle, this is really basic graphing. Start at the center. Well, it's just x squared and y squared, so the center is at the origin. It'll move left or right, just like any of the other graphs move left or right. When it's with x, it goes left or right. When it's with y, it goes up or down. And then your radius is 3. So from the center, if that's my radius, by definition, the radius is that distance from the center. Well, the easiest distance to go 3 is going left or right and going up or down. Because the radius is 3 any direction around the circle. And the easiest thing to do is to go vertically and horizontally. And then make yourself a little circle. That's it. Graphing a circle is pretty easy. Did you guys do graph circles in geometry?
No.
No?
If it wasn't approved.
If we had something like -2 in front of x squared, would it move left or right?
The -2, actually, if it's in front of x squared, so it would look like x minus 2 quantity squared. And that would move right. So if the 2 was in front, that would actually like stretch or shrink the circle. Other questions? So if it's in parentheses with x, x minus 2 would shift the center then to the right. So everything's based off of the center. Questions? You don't like your circle?
No, I can't draw one side.
Oh.
One side looks really nice. Mine's better.
The last, I'm sure it is. The last one, Zach, what kind of graph would be an absolute value graph?
The other one does like V graphs.
It is a V graph. Where does this V graph move?
Alright, so it moves down 1 and it moves left 2.
Good. So down 1 and it goes left 2. So that x plus 2 being with the x and the absolute value is moving at the opposite direction. And then to get the rest of the graph, it's supposed to look like a V. So using the same concepts, if I go right 1, Zach, what's the absolute value of 1?
1.
If I move right 2, the absolute value of 2 is?
2.
2. If I go left 1, the absolute value of -1 is still?
1.
The absolute value of -2 is? 2. And then you have a couple points to make a V. So again, whatever is happening with x is how you're getting the vertical points. So if x is cubed, you're cubing x. If x is squared, you're squaring your x value. But that's how you know how high to go or low. So as I said, that I should have a cube root graph on there, but I don't. The cube root graph is the elongated s. Kind of like stretches and pulls. That would be your cube root graph. Very similar to the square root graph, but it has the other side of it as well. So the cube root of x would be the one that pulls it left and right. So in your packet, we're going to see if we can graph 3 different systems. So hopefully that was a little refresher. On your homework tonight, some of it's matching. You're asked to kind of write a couple of pieces of information instead of just writing a letter. And then there are 5 or 6 graphs that you'll be graphing by hand. And in your packet, it's page 25. So the first one's pretty straightforward. It says our goal is to graph inequality graphs. To graph inequality, we actually graph the equality and then decide which part to shade. So you're graphing the line or the parabola, and then you're deciding where to shade. The first one says to sketch the inequalities, find the vertices of the shaded region. So the vertices are those 2 locations where your lines are connecting and kind of bounding the region, stopping it from going beyond that location. The first one we have is x minus y is less than or equal to 2. So Aaron, what would you do with x minus y is less than or equal to 2?
Get y on one side.
And if we got the y on one side, what would it look like?
Y equals, or is less than, negative x plus 2.
Okay. And then,
Y is less, does it stay as less than, or is it greater than, because it's dividing by 2?
yeah, when you divide by a negative, you flip this sign, so it becomes greater than
X minus 2.
x minus 2. So with inequality, remember multiplying or dividing by a negative, not adding or subtracting a negative, multiplying or dividing. You have to flip that sign. So now we have y is greater than x minus 2. So this is our line going down to negative 2, moving right 1, up 1, right 1. How do you connect that line?
I always forget my phone.
Emily?
It was about a line.
Yeah, it is a dotted line? Yep.
I always forget to draw.
I drew a nice solid line there.
Yeah. Because you're just so used to drawing solid lines.
And I just go, I have to go back to the eyes and take marks with my eraser.
And mine, and the dots just take so long to do.
I guess so. Did you have to pick out your pencil and break it down? I don't know
I
exactly.
did, it was a solid line. And then
So again, dotted line, and then we're shading above now. So just kind of remind yourself if you need to. I'm going to put 2 little arrows there to remind me I'm going up. The next one is x is greater than negative 2. Emily, what kind of line is it when it's x? Vertical, right. So x is a vertical line over to negative 2, vertical line. Remember, it's dashed because it says greater than, and greater than means to the right of a vertical line. Don't forget the dash. Kyle, the last one is y is less than or equal to 3, so that would be a straight line, horizontal at 3. Solid or dashed? Solid. This one's the solid line because it has less than or equal to. And that's below. So we have a triangular region. So then it asks you to list the vertices of the shaded region. So where are the vertices? David?
Is it where the lines connect?
Yes. Yep.
Okay, so then there's one at negative 2, 3. Negative 2, negative 4.
Mm-hmm.
And then one at 5, 5, 3.
5, 3. Which one of those 3 would not be a solution? David?
The negative 2, negative 4.
Yeah, this one is the only one that's not a solution because both of those are dashed lines. So it would not be a solution. The other 2, the one is a solid line, and if it lies in that solid line, it's a solution. But the negative 2, negative 4 wouldn't be a solution. It creates the boundary for it. It's a vertice, but it's not a solution to the system. Questions? So the second one think we have two inequalities. Sketch the region containing all the points that satisfy the following. So this one's a little more interesting because we have a squared term. X squared minus y squared is less than or equal to 1. And then negative x plus y is also less than or equal to 1. Anna, what would the equation be for the x squared minus y squared?
Y is greater than or equal to x squared minus 1.
Right. So subtract the x squared, divide by the negative. Don't forget to flip the sign. And Anna, this shape is a parabola. So this is our parabola because x is squared. The minus 1 tells us to move down to negative 1. And then you're squaring x. So from this point, if x is 1, 1 squared is 1. If I go right 2, 2 squared is 4. Right 3, 3 squared is 9. And then going the other direction as well. Negative 1 squared is still 1. Negative 2 squared is 4. Negative 3 squared is 9. And a solid or dashed line?
That'd be a solid.
Yeah, this time it's a solid line. Has that equal to? I guess it's not a line, it's a curve. Solid curve for a parabola. So now we have our parabola. Nina, how about solving the second inequality, or y?
It would be y is less than or equal to x plus 1.
Good. So that one is a line up at 1, and then the slope is up 1 over 1, down 1, backwards 1. Solid or dash, Nina? Where's your solution? So greater than or equal to x squared minus 1. David?
In that little hole in the two of them.
Yeah.
Right in there.
So this little curved region close to the vertex. So greater than or equal to would mean anywhere inside the parabola. That's going to be greater than or equal to. Less than would be on the outside. So if you go to a point, less than is down, greater than is above. So any of your points go greater than it. And then we're less than the line, so we're in that little curved region there. The vertices of this region would be at 1, 0, how about negative 1, 0, and 2, 3. If your two lines don't intersect, how can you algebraically find the intersection point? They don't intersect in a nice location. I should clarify that. So if they don't actually intersect in the corner of a box, how can you figure out where they intersect? One happened to intersect like in the middle of the box.
We use our calculator.
You could use your calculator, but you can't on Friday. How could you find out where they intersect? Ethan?
Do a system of equations.
Yeah, just use substitution. So if I wanted to find out where they intersect, you could take system of equations, set this one equal to that one, and it's going to be factoring, but you could find out where they intersect by taking one and setting it equal to the other. That gives you the intersection point. That's what we did in the first part of the chapter. We were finding out where they intersected. So we're going to do one more problem on the back. There's a word problem there, but we'll save the word problem.
Okay, would 0, negative 1 be a solution to?
That would be, yes, that would be considered like part of your bounded region because that's the vertex of the graph.
So that's not like a solution then?
It's
That's
not,
like
it's not a vertex, no.
Okay.
If you were asked, like number 3 here says find the maximum value, we would use it to find the maximum value of the graph. So this last question here wants us to find the maximum value using this equation z equals 3x plus 2y. And then it says subject to the following constraints. A constraint is another way of saying a system of equations or a system of inequalities. It's just a restriction. So we have these 4 inequalities. We're going to see if we can use these 4 inequalities to try and find a maximum value of the 4 inequalities. So when you graph the first 2, if x and y are greater than or equal to 0, that's just forcing x and y to be positive. So you have the vertical line at x is greater than or equal to 0, the horizontal line y is greater than or equal to 0. That just means all my answers are going to be up here in the positive quadrant. And then the third equation, we have x plus 2y is less than or equal to 4. Zach Dickinson, what would that third inequality give you if we solved for y?
Y equals negative, or y is less than or equal to negative 1/2 x plus 4.
Plus, you're so close. Divide everything by 2.
Oh, okay, then plus 2.
Plus 2. You don't flip the sign there because you're not dividing by a negative number, you're just dividing by a positive. So we have negative 1/2 plus 2 up 2. And then negative 1/2 means down 1, right 1. And solid because it's less than or equal to. David, the fourth inequality, what's that equation? Or inequality?
Y is greater than or equal to x minus 1.
So that one goes down to a negative 1, slope of just 1. And that flipped the sign to be greater than or equal to. What shape is our region that we're filling in?
Try.
Close.
No?
Oh no, I was just gonna say a random shape. I was gonna say dodecahedron, and I know that's completely
How many
wrong.
sides does it have? I would have like 12 sides.
It looks like a triangle to me.
So
It's
it's a quadrilateral.
Oh.
It has 4 sides.
Oh, it's really
Oh, I
tiny.
accidentally
Did you
drew
go down all the way?
Yeah, I went down.
Yeah, it's really tiny. But the horizontal line at y equals 0, that makes it into a 4-sided quadrilateral. It doesn't have a specific, just quadrilateral. So, what are the 4 vertices?
It's a rhombus.
Not a rhombus.
I don't even know the rhombus.
I just have 2 pairs of parallel
Can we
sides.
name it?
Not a parallelogram. All right, so one ordered pair is 0, 0. Another ordered pair,
0, 2.
0, 2. How about a third ordered pair?
1, 0.
1, 0, and one more ordered pair.
2.
2, 1. The corner point principle says your maximum or minimum value will occur at the corner points or the vertices. This one is asking us to find the maximum. If it's not a maximum or a minimum, it's in the middle of the graph, and it gives us a number that would be in the middle of those maximum values. So if we want to find the maximum value, I'm just going to make this as like a little t-chart. You're using this equation, 3x plus 2y. You're plugging in your ordered pair. Whichever one gives you the largest number is your max. Whichever ordered pair gives you your smallest number would give you your min. But it has to occur at the vertices. That's the corner point principle. So if it doesn't occur at the vertices, then it's a number in the middle. So obviously when you plug in 0, you're going to get 0. When you plug in 0, 2, that gives us 4. 1, 0 is going to give us 3. And then 2, 1 looks like should give us 8. So what is the maximum value, or find the maximum value? Well, 8 is the maximum value. It occurs at the point 2, 1. So when we go to do the word problems tomorrow and Wednesday, this will usually represent something. So I should make so many objects of x, so many objects of y to give me a maximum or a minimum profit, or a maximum or minimum cost. So they kind of apply more to word problems. So make sure you're following the directions on the assignment sheet. I think everybody's okay getting into the book now. Hopefully, have a great night.